Good morning, sir. Myself Neeraj Kumar from CSCD section. My topic is about CPU scheduling with example. On moving on to my first slide, first of all, introduction to CPU scheduling. CPU scheduling is the process of determining which process will use the CPU at any given time. Efficient CPU scheduling improves system responsiveness and CPU utilization. Different algorithms exist, each with unique advantages and also disadvantages. And then, what is the main importance of the CPU scheduling? Let's see. CPU scheduling is crucial for maximizing CPU usage and minimizing wait times. It directly impacts the overall performance of a computer system. Proper scheduling can lead to better user experience by reducing latency. And then, what are the types of the CPU scheduling algorithms? There are several types of the CPU scheduling algorithms used in operating systems. The main categories include non-preventive and preventive scheduling. Each category has specific algorithms designed for the different scenarios. In the beside picture, you can see the tree diagram of a CPU scheduling algorithms. And then uh, first come first served, FCFS. So FCFS is the simplest CPU scheduling algorithm based on the order of arrival. Processes are executed in the order they arrive in the ready queue. While easy to implement, it can lead to the conway effect, causing delays. And then example of the FCFS scheduling. Consider three processors P1, P2 and P3. So P1 will complete at 4 ms and P2 at 8 ms and then P3 at 10 ms. The average waiting time for this example is 4 ms. And then shortest job next, SJN, also known as shortest job first, selects the process with the smallest execution time. This algorithm minimizes the average waiting time for a set of processes. However, it can lead to starvation for longer processes. And then example of the SJN scheduling. Consider two processors P1 and P2. P2 will execute first and completing 2 ms, while P1 completes at 8 ms. The average waiting time here is 3 ms, which is better than the FCFS. And then round robin, RR. Round robin is a primitive scheduling algorithm that assigns a fixed time slice to each process. It is designed for time sharing systems and enhances responsiveness for interactive users. The context switching overhead can be high if the time slice is too small. So let us see the example of the round robin scheduling. Consider three processors with a time slice of 2 ms, P1, P2 and P3. The execution order is P1 greater than P2 and which is greater than P3. The average waiting time is 5 ms in this scenario. Priority scheduling. Priority scheduling assigns each process a priority level for execution order. Higher priority processors are executed before lower priority ones. Starvation is a concern as low priority processor may never execute. And then what is the example of the priority scheduling? Let us see. Consider three processors P1, P2 and P3. P2 executes first, followed by P1 and then P3. The average waiting time in this example is 4 ms. Multi-level queue scheduling. So the next one is multi-level queue scheduling. Multi-level queue scheduling divides the ready queue into several separate queues. Each queue can have its own scheduling algorithms based on process type. This approach allows for differentiated treatment of process based on their needs. So the example of the multi-level queue scheduling. Consider two queues, foreground, which is also known as interactive, and background, which is batch. Foreground might use RR while background uses FCFS. This allows for efficient processing based on the nature of the task. So finally, the conclusion on the CPU scheduling. Effective CPU scheduling is vital for system performances and user satisfaction. Understanding different algorithms can help in choosing the right one for specific needs. Continuous improvement and adaptation of scheduling strategies are necessary for evolving systems. And then the future of the CPU scheduling. How it will be in the future, let us see. Future CPU scheduling may increasingly rely on machine learning algorithms. Adaptive scheduling could optimize performance based on real time data. As systems become more complex, innovative scheduling solutions will be key to the efficiency. And thank you.